Hello friends, my name is Wankhede and today I am going to explain deadlock detection and deadlock recovery, which is the part concept of operating system. So deadlock detection and deadlock recovery is that we will let the system to happen the deadlock and then we will recover from that. So detection can be performed by two types. One, the resources, if the resources is of single instance, means only one copy of each resources is present, then we will apply the detect cycle algorithm. If the multiple instances, means two copy of resource 1, three copy of resource 2, such situation was that, then the safety algorithm will be applied. So we'll first consider the first case, single instances of each resources. This algorithm will work if resources will have only a single copy. Resource 1, one copy, resource 2, whatever the resources are there, only one copy of that resources will be there. For this, we will apply the new version of resource allocation graph, that is wait for graph. So the wait for graph is constructed from resource allocation graph. This is the extension of resource allocation graph. It is constructed by eliminating the resources. The wait for graph does not have the resource constraint. It will only have the processes. And then we are collapsing the associated age that will be shown in the next diagram. In the wait for graph, the arc from process 1 to process 2 indicates that process 1 is waiting for process 2, a resource which is holding by process 2. So this is the example. The first diagram is resource allocation graph and the second diagram is wait for graph. In the resource allocation graph, there is two vertices, one process denoted by circle and one resource denoted by the rectangular box. Whereas in wait for graph, there is only one vertices, is the process, which is indicated by circles. So we'll first convert this resource graph to wait for graph. Now how we'll convert? We will just first remove the resources from the wait for graph and we will combine the edges. For example, see process 1, the arrow goes to resource 1, means process 1 is waiting for resource 1. Then resource 1, the arrow goes to process 2, it means the resource 1 is holding by the resource process 2. So if you want to convert to the wait for graph, just remove the resources. So we have removed the resources and just combine the arrow from process 1 to process 2. It means that process 1 is waiting for process 2 because process 1 want the resource R1 which is held by process 2. So there is a direct arrow from process 1 to process 2. So you can see in the wait for graph figure 2, there is a direct arrow from process 1 to process 2. Next, from process 2 to resource 3, there is one arrow, and then resource 3 to process 5, there is one arrow. So just remove the resource R3 and combine the edges. So in the diagram will be process 2 to process 5, there is direct arrow. So here we can see in the second diagram, process 2 to process 5, there is direct arrow. It means that process 2 is waiting for the resource which is held by process 5. Now similarly, process 2 to R4 is one arrow and R4 to P3, that is one arrow. So we just remove that R4 and we will combine that arrow. That arrow will goes from process 2 to process 3. So in the wait for diagram, you can see that from process 2 to process 3, there is a direct arrow. Similarly, from process 2 to R5, there is one arrow, and R5 to R4, there is one arrow. So we will first remove that R5 arrow and we will directly combine P2 with P4. So there is you can see in the second diagram, P2 to P4. Similarly, we have combined P4 to P1 and P3 to P4. That is wait for graph. Now, deadlock, this wait for graph is used to detect whether the deadlock has been happened or not. So in the wait for graph, if there is a cycle, then deadlock is happened. If there is no cycle, no deadlock is happen. So you can see that there is a cycle from P1 to P2, P3, P4, and then we'll reaching to P1 again. And P1 to P2, P4 and P1 we are reaching there. So you can say that the cycle is present, the deadlock is present. The cycle is present for which process? Only that process is been there for deadlock existence. So P1, P2, P3, P4 is the reason for where deadlock is occurred. Because of this process, the deadlock is there. P5 is not leading to deadlock. The second is for several instances of resource step. The previous resource allocation graph, wait for graph, it is applicable if only one copy of resources is present. Now the next algorithm is the several instances. This is a new version of Banker's algorithm. The same, there is two vectors. There is one is work and one is finish. We'll first what do? We will assign the available to the work, and then we will make the finish of every process as false, that no one process has executed it. Then for each process, what we will do, we'll check whether the finish of I is false and request is less than work. If such thing is there, then we will go to the step 3. The step 3, sorry, it is not mentioned, but step 3 is work. Otherwise, if no such I exists, we'll go to step 4. If the condition is true, that finish of that process is false and request is less than work, then we will make work equals to work plus allocation and finish of I equals to 2. We will repeat for each and every processes. At step 4, if the finish of I is false, what we have to check, we have to detect the deadlock. So we will find out which process condition is false. Okay. So we'll check for 0 to n for every process. If any single process is holding false, then there is a deadlock. And we'll find which process is holding false, that process is leading for the deadlock. So from deadlock detection, we're finding out that which process is leading for the deadlock. We're finding out such processes. So here we'll find the deadlocks. Then the deadlock recovery. Now the deadlock has happened. We have to now recover from that deadlock. So the very first is process terminal. What we do, we will just abort that process. So we can do two methods. So one is we can abort all the process which is leading to the deadlock. Or what we will do, we will abort one process, then check whether the deadlock is happen or not. If it is happen again, we will abort one more process, then again detecting the deadlock algorithm. If there is a deadlock, we'll aborting the one more. So step by step, one after the another, we will aborting one process, then checking the deadlock is there or not, then again aborting one process. So we can do that. So there is two method. First is we can abort all the processes which is leading to the deadlock, or what we will do, we can step by step, one after the another, we will abort and process and check that process. Now how you can choose that which process to be aborted? So for that there is various criteria. The word first is what the priority of the process. So we can decide that low priority process can be aborted first, or we can decide high priority process can be aborted. So based upon the priority, you can choose the process. The second, how long the process has computed and how much longer the process will complete before completing itself. It means that, for example, process 1 has completed 75% of task and process 2 has completed, for example, 60% of task. So you can choose that which is completed, which is maximally completed, we can abort that process, or which is lesser completed, we can abort that task. So in this example, the process 1 has process 1 has completed 75 and process 2 has completed 65 tasks. So we can abort the process 2 which is having the less completion task. Then the third is how many and what type of resource that process has used. For example, whether the process are simple to preemptive. We can have the concept of that using the preemption. So we can take away the resources of that process and we can use that process. How many more resources the process need? The one option is that if process 1 requires 5 more resources and process 2 requires 3 more resources. So we can choose the maximum resource holding process and we can abort that process. How many processes will need to be terminated? So based upon that, so process 1 is terminating and releasing 5 resources. Process 2 is terminating and releasing 3 resources. So maximum who is releasing that resources we can use to abort. The last is whether the process is interactive or batch process. Interactive means this, he is continuously coordinating with the system. He wants the continuous input from the system, that is interactive. And in the batch process, what has happened? All the inputs are given at the starting and then the process will be executed. So you can choose which process you have to abort, interactive or batch. The next is the resource preemption. So what we can do is that we can preempt that resource. So preempting means we can take away resources of that process and assign to another. Such can be happen so that, and we can check that deadlock is broken or not. The cycle of the deadlock is broken or not. So preemption, we can preempt that. We can take away the resources from that process and give to another and check whether the cycle has been broken or not. So when we are preempting, we have to deal some concept. The very first is selecting a victim. We have to first choose which process we have to preempt, on which resources we have to preempt. So victim is choosing the process or resource that we have to preempt. The second step is rollback. Now you have selected the victim, means you have selected which process you have to preempt. Then we have to do the rollback. The rollback is nothing but going one step back and check whether the deadlock is break or not. The third is starvation. Now very first, what is the starvation is that starvation means if you are choosing the same process repeatedly and roll backing that process repeatedly, it means the starvation. So choosing same process repeatedly and making that same process roll back is called as the starvation. So instead of that, pick such resources and find and pick the victim which is choose smallest number of time. So these are the three conditions. First choose the victim, first choose the process, then roll back the process. And after roll backing, if you are choosing a same process repeatedly, then the starvation will happen. So don't choose such process, don't choose the repetitive process. So thank you.